So I wanted to make this little video about how the federal cash register works. And I thought this was pretty interesting because it's actually very similar to the NCR 135 principle. So similar, in fact, that, looking at it, it almost feels like they were reading through old NCR patents and decided to use that mechanism, which is kind of interesting because the 135 principle mechanism from NCR is in itself an interesting mechanism. I should say the hallmark of it is the oscillating shaft, which we can take a look at right on the side here. So you'll notice that the slot cut out for the shaft, it looks like it's worn out, that there's a good deal of play in it and like this has worn off here or something, but no, it's actually supposed to be that way. This whole shaft rocks back and forth during the cycle of the mechanism. And you can see this arm here, which is attached to the shaft, goes up to here, and that's actually the pivot point. So this whole thing pivots back and forth on this up here, which I'll show you in a moment. So I just thought it was pretty interesting that Federal decided to use that mechanism, because that in itself is an interesting mechanism, and you would think that that would, wear out, that, over time that slot would wear bigger and bigger as the shaft oscillates in it, but on both this register and I also have a NCR 135 principle, and there doesn't seem to be any wear there, so I guess the force is not, great enough to wear it out as long as it's got grease in it, but still an interesting design choice there. Other than that, it operates, like your regular key operated cash register. You can push down, one key at a time. Actually, you could if I unlocked it. It has this lever control here. So right now it's in locked mode. That's open or closed drawer mode. So the drawer has to be closed or the register is locked, which I don't have the drawer on right now. That's open drawer mode, so it should operate like that. Oops, it wasn't all in frame there. Try that again. So you can see that it does operate. I'll take a look at that oscillating shaft in operation. So you can see for each cycle of the machine, the shaft oscillates back and forth in that widened out groove there. So yeah, pretty interesting design. The basis of this mechanism is a reciprocating principle. So if we look down inside there, right there is a cast iron slab which oscillates up and down. It's gonna be a little bit hard to see, but you can see it down in there. See, it rocks up and then rocks down again. And the rocking action of that cast iron slab, it pivots. Oh, you can't see it on this side. It pivots here, but it also slides back and forth. So if you watch as I operate this, see the whole shaft popped out and then popped back in again. So that whole cast iron slab with the shaft oscillates back and forth. You can probably get a good view of it here. So this is how it actually interacts with the rocking shaft. If I can get it in frame. So you'll see this piece here is actually a cam that will push on this knob, which rocks the oscillating shaft, forwards in this direction, and then that knob rides on top of that cam. So you can see now the shaft has rocked forward. It's riding on top of there, and then once the cast iron rocker gets to the top of its travel, it stops over. Out from underneath that cam, allowing the pivoting shaft to rock back, and then the cast iron slab, also rocks back and then goes back to its home position. So, yeah, definitely very, in my opinion, it's a very weird way of doing things. I think the NCR 135 principle was made from, I think, 1902 to 1906 or 1908. So it wasn't made for very long, relative to the 35 principle and the 79 principle, but it's made for a couple years as a cheaper alternative to the 35 principle, but still a total adder instead of the detail adders. But yeah, and this is pretty similar to that mechanism. let me see. It's going to be kind of hard to show, but I think I'll be really able to show. I can kind of see here. So this piece here is one of the this piece here and the piece next to it are what push the cast iron rocker and its shaft in this direction at the end of the cycle. And then this one over here, and you can't really see it on the bottom, I don't think. You won't be able to see in there, but on the top of the cast iron rocker, underneath that, is a finger. And so when the cast iron rocker rocks up, that finger pushes against the bottom side of this beveled cam face here, and that's what pushes the whole thing over at the top of the cycle. And then it remains over as it, rocks back down to its home position. And when it gets back down to the bottom, then this cam, this beveled cam here, and that finger push it back that direction into the home position. So you can kind of see that maybe here. So see how it rocks back? Now it pushes over due to the finger on the bottom hitting that cam. Now it stays over on the way down, and you'll see how that finger there contacts the beveled face of the cam, and that pushes the whole thing back over to the right, back to where it belongs. So I hope that makes sense as to how that works. It's the interaction between the rocking cast iron slab, that beveled cam face, that beveled cam face, and then of course the weird rocking shaft there. So as far as how this mechanism actually adds, you can see we've got the counter assembly here. So this is the total counter, or the accumulator. NCR always calls it the total counter, but technically it's an adding register, not just a plain counter. These two here are plain counters. This is the customer counter, and this is the no sale counter. And then this over here is the reset counter. Right now this is in open drawer mode, so normally these would not be visible outside of the case. If we go to expose totals, now we can see the current total is $38.16, and we have 9 on the customer counter, and we've got 2 on the reset counter because I just finished rebuilding this assembly and reset it 2 times since I've finished putting it back together. Pull it once again, and then it goes into reset mode, and then that exposes a keyhole on the side there where you can use the reset key, which resets resets the accumulator, the no-sale counter, and the customer counter, and then increments the reset counter. And that reset key is this key. Actually, this is the only reason I know this is a federal cash register, because it says so on the key. When I got this, there was no decal or anything on the cash register case to dictate the maker, so I didn't know that until I found this key in the cash drawer. And that just goes in the side here, and you just turn to 0. You'll see that everything has zeroed out, and our reset counter now reads 3. Push this back into open drawer operating mode. Yeah, so how does this actually work? So you see we've got a row of keys in the front here. These are actually 2-part keys. So there's one piece of the key pivots on the shaft right down there, and see it's got this comb down there to keep everything in alignment. Then that goes up, kind of up, and then hooks into another piece. And then those other pieces pivot on this shaft up here. You can kind of see the tops of them there. So this, actually, you almost kind of see where they connect back in there. So I'm wiggling the key, which it would focus, and you can kind of see what it connects to the other piece. Basically, there's a slot in the other piece, and then the key has a pin on it, and then the pin goes into that slot. And it's slotted so that as you push the key down, you can see it kind of rocks up on that other piece. And then because they have different pivot points, it has to be slotted because that position is not fixed relative between the key and that other rocker piece. So basically, when you push the key down, it also rocks up on that rocker piece, which you can see the tips of it the tip of it wiggling there. So when you push down on the key, two things happen. One thing is, you can kind of see down there, right underneath that cast iron slab is a shaft, so right back there. That shaft rests on the upper rockers, and you can see as the upper rocker gets pushed up, it also pushes up on that shaft and starts the rocking action of the cast iron slab. Additionally, you can see this piece, which is part of the same piece. The point up here is pushing on this rod, which is kind of in the shadow. Now I pushed it down too far, so I have to keep going. But you'll see as I push it up, it latched onto this shaft and took this whole thing and rocked it along with it. This is the adding segment. So basically, when you push the key down, two things rock. The first thing is the cast iron slab down at the bottom. That rocks up along with it. And the adding segment, particular to the decade, also rocks along with it. So you see we have three adding segments because we have 3 decades, cents, tens of cents, and dollars. So this one here is for the dollars, this one here is for the 10 cents, and this one here is for the cents. And these are directly connected to these geared segments here. You can kind of see that the segment comes up and it just has this geared segment bolted onto it. And that geared segment directly drives the register gears down there. You can see these 3 segments directly drive these 3 register gears for the dollars, the tens of cents, and the cents. And then for the carries, you can kind of see these little trip things down in here. So how that works is, for every cycle, these fingers here are pushed in. Let's see if I operate. See, they get pushed in one after the other. So those are the carry fingers, and you won't be able to really see it, but down in there's a hook. So if you notice, I don't think you'll really be able to see that. We'll see if I can. Yeah, so you see next to the gear teeth, there's a ratcheting part of the register drive, or the register gear rather. And that ratcheting part serves 2 purposes. One is as a ratchet. You can see the ratchet tooth here preventing this from being turned backwards because it ratchets on these ratchet teeth. The second thing is on the bottom, there is a finger that can pull in and advance each one of these by 1 position. And that's the carry finger. So basically, that finger is the end of this shaft here. So every time these shafts are operated as part of the cycle, they have the opportunity to grab onto the ratcheting, one of the ratchet teeth here, and advance each of these wheels by 1 position. Normally, they're held down, and so they just bypass the ratchet tooth and don't grab it. But if a carry is needed, they can spring up and grab the ratchet tooth and pull the wheel 1 more position. And you can see these got these springs on here that assist with that. So let me see if I can show this. Right now I've got 0 and the 10 cents. So that when you put in 50 cents, oops, I can't do that. Well, it's very hard to see because you can't operate it with the register open. So now I put in 50 cents. And now I'm going to put in another 50 cents. See if I can get it to go slower. So see how the carry finger right there tripped that little trip? That's going to allow the ratchet that ratchet hook to spring up and catch on the ratchet tooth. See if I can catch it in operation here. So see, now it's pulled out, so that should have, there it goes. So you see when this carry finger is actuated, it pulled the dollars wheel 1 position forward, because that trip had allowed the finger on the bottom to spring up and pull on one of the ratchet teeth. So I hope that makes sense. Again, basically the exact same way that the NCR 135 principle works. And these carry fingers are actuated, I think you'll be able to see, on the, you can kind of see the red grease on the very tip of it there. Those fingers are pinned to the shaft that the cast iron rocker is pinned to. So as the cast iron rocker rocks up and back down, those fingers push on the ends of these rocker sections, and that's what actuates those. So it's just the rocking action of the cast iron flapper there with its shaft that actuate these carry fingers here. Yeah, so this piece here, this is just a lock. So right now you can see the deck A segment is locked, but if this gets pushed back, you can see the deck A segment becomes free. So that's just a safety thing, I guess, to prevent unwarranted movement of these deck A sections. So basically the deck A section is always positively, attached to something. Either it's locked in place and can't move, or it's unlocked, but at the same time one of these risers here is grabbing onto that shaft and actuating it to its desired position. So it's always either locked or being driven. It's never like free floating, basically. Other than that, for the counters, these are pretty basic counters. These are spring-loaded finger assemblies here, and they just push on the ratcheting segments of each wheel there. And then when it needs to do a carry, there's a deeper cutout in the ratcheting section, which allows this, why is it not in focus? Which allows this to spring in deeper and just grab the ratcheting piece on the next wheel. And then same thing if it needs to carry to multiple columns, then this finger will drop into the deep groove. This finger will also drop into its deep groove, and then this finger will engage with the ratchet in the next column. And just a pretty simple assembly there. And most of the cash register counters work in a similar way. Both NCR and most brands work that way. The reset counter is pretty simple. There's just a finger pinned to the shaft. So when you put the reset key in the end and turn it, this whole shaft turns, and that just turns the finger around, which drives this gear, which increments the digit by 1, and then it's just a simple. Why is focus so bad? Just a simple, you can kind of see one of the fingers there on the next wheel. So every time this gets to 9, then the finger will drive this gear, which turns this wheel on position, and then so on and so forth. It's just a very simple counter assembly there. As far as the flags, and standard on cash registers, the tail ends of the keys push up on the bottoms of the flags and raise the appropriate flag. In this case, because there's those 2-part keys, it's the secondary upper part that pushes on the flags, but basically the same idea. The flag release is controlled by this assembly in there. So you can see that it has an arm going back, and that arm connects to this piece right here, which pushes on this roller, and when this roller is pushed on, this whole thing kind of moves out and back at the same time, and that's the flag release. So see if I can catch that in operation here. See how that's pushing back? So that's released the flags now. That is pushed back. And you can see the other flag is now coming up. As I keep going, it releases that and allows it to fall back down. So that's also driven by a little finger. You can see the little finger down there, right there. That's also part of the cast iron rocker assembly. And then on the front of the thing here, you can see down there, it's the bell clapper. There's also you can see the finger all the way up in there. That's also attached to the same cast iron rocker shaft, and then when the shaft rocks forward, that finger pushes up on this and then drops it to ring the bell. Yeah, I think that pretty much explains it. It does have a ratchet. You can kind of see right there. We'll focus on that. There we go. So as you push up, you can see that that ratchet springs up and now ratchets, and then also ratchets the other way too. So you have to push the key all the way down, and then let the key come all the way back up before you can push another one. And this does have, you know, tandem operation, so like I can push, you know, $2.90 at the same time. And the same thing I could do, like, you know, dollars, tens of cents, and a cent. But you can't really do that. Actually, I guess you could kind of do that. Better to do that with two hands, but it is possible. You can see that then it registers, you know, $4.98. Yeah, so this counter is actually, you know, a full parallel, you know, adder type counter, because it can add into all positions at the same time, or just these three positions. And then from here over, it's like a regular, you know, there's a finger on here that when it gets to 10, it increments the next position, and so far, all the way over, just a regular basic ripple carry counter for this part. And then these three wheels here are the actual, you know, adder accumulator type section where you can parallelly add to each column individually, and then, you know, the carries work as expected. Yeah, so I think that's about it. On this side here is the control mechanism, so it just has this detented thing there. This piece here is the counter shield, so when this is pushed into a position where the counter should not be exposed, it just pushes on the little peg there and hides the counters. All the way forward is locked, so right now it's locked. That just locks this piece here into position, and this rod here is attached to the cast iron rocker. So if you try to push a key, the rocker can't operate, and that's your locked register position. This shaft down here runs over to the drawer mechanism, which you can kind of see up in there. You can see the shaft running across there up to the drawer mechanism there. So you can operate it in either open drawer or closed drawer mode. So when it's in closed drawer mode, it allows a finger to spring in that basically blocks the cast iron rocker from moving. Then when you push the drawer in, it, you know, moves that finger out of the way so that you can operate the register. And then in open drawer mode, it moves that finger out of the way permanently, so you can operate the register whether the drawer is open or closed. So yeah, I hope you enjoyed this little look at this federal cash register mechanism. I definitely thought it was very interesting that, you know, of all the mechanisms out there, they chose to base it off the NCR 135 principle. Because I'm assuming this is from probably the 30s or 40s. Could be the 50s. I'm not really sure when this was made. As far as I'm aware, there's no way to look up dates for federal cash register serial numbers, but yeah, I would think by the time this was made, the NCR 35 principle would have been, you know, out of patent period, like the patent would have expired. So I would think that would also have been fair game to use, because actually that was designed before the 135 principle, so that would have been, you know, in use. They released that back in like 1892, so I definitely would have thought that would have been, you know, out of patent by this point, but I don't know why I didn't use that and they went with the 135 principle. But anyway, just thought that was interesting, so wanted to show that. So hope you enjoyed this video, and thank you for watching. So I realized I forgot to explain the purpose of the rocking shaft on this mechanism. And the purpose of the rocking shaft is, you can see, so this shaft right here is the rocking shaft. You can see it's cut out there. And that is what these pivoting pieces with the tooth segments on ride on. So the point of that rocking shaft is to engage and disengage those segments with the counter. So for example, if I go on the side view here, inside of the machine, as soon as I push a key down, these rocking segments will rock forward to engage with the counter because the whole shaft rocks forward. And after they finish driving the counter, or the accumulator, whatever you want to call it, then they will, you know, rock out and disengage once the shaft rocks back. So I can get that all in frame here. See how they move forward to engage, drive, drop out of engagement for the return stroke. Because obviously you want the counter to, only turn forward. So on the return stroke, they have to disengage. Now, that's true for all reciprocating machines, like the burros, anything like that, where there's a reciprocating action and the driving rack, or whatever you want to call it, that actually drives the counter, moves one direction on one half of the machine operation cycle, and then another direction on the other half of the machine operation cycle. You have to engage and disengage as appropriate, so that you only drive your counter in the appropriate direction, or your accumulator, or whatever you want to call it. Now, normally on other machines, the actual counter is pivoted and will drop into and raise out of an engagement. For example, on the Bros machines, like on the Class 1, the counter itself is pivoted and will rock backwards to engage with the two segments on one half of the stroke, and then will rock out of engagement for the return half of the stroke. But for some reason, on this style mechanism, which is this federal cash register and the NCR 135 principle, the counter is fixed. So you can see the counter is solidly bolted to this cast iron piece here, and it doesn't move. Only the two segments move, and you see if we can get a top view here of it operating. So they come into engagement, drive the counter, then fall out of engagement for the return stroke. And that movement you saw there was just the carry. So there is no input from these two segments on the return stroke, because that rocking shaft has moved backwards and pulled the two segments out of engagement with the register. So I just realized that I forgot to explain that, so I'll add that on the end of the video. I hope you enjoyed this video, and thank you for watching.